So now we are ready to present complete details of the leader protocol. So a leader keeps track of the following variables. Leader remembers the identity of the leader, the last leader reported by Omega. My ballot keeps the current ballot or the last ballot executed by this leader, and it is initially some minimal ballot B0, and also it has a Boolean variable decided, which remembers if the leader reached decision. So whenever eventual leader detector reports that it trusts a process with ID P, then this ID is stored in the local variable leader. Okay, so whenever we have this condition here satisfied, that is the process itself is the leader as reported by Omega, and this process has not yet decided, then it executes the following steps. So first it computes the new value of my ballot, and this value is computed so that it is equal to a ballot B, which is A, unique, and B is greater than my ballot. And this is actually important, as we will see. So this actually, computation here ensures that the values stored in my ballot continue to grow. Okay, so my ballot keeps increasing. Okay, so then the leader activates a new instance of abortable consensus with this ballot my ballot just computed. So as we have said, abortable consensus may not succeed, in which case it returns abort. But if it does succeed, so if the returned value is not abort, then the leader decides, basically says it sets the flag decided to true, and it triggers local decide decision, and it also propagates this decision to all other processes so they can learn of the decided value. Okay, and whenever a process, any process, so that can be any process, and not just the leader, receives the receives this decide message for a value V, and this process has not yet decided, then this process decides. Okay, so it triggers the local decide event, and of course it also sends the value of the decided flag to true to prevent any repeated decisions. Okay, so this is the last piece of the puzzle, and that actually completes our presentation of the Paxos algorithm. So next, let's see briefly why it is actually correct. So validity and integrity are simple, so we briefly argue why Paxos satisfies agreement. And so that's actually followed from the conditions that we discussed. So abortable consensus, which is the algorithm that determines the decision value, maintains property P to C. Okay, and as we have shown, P to C implies property P2, and the property P2 is as follows. So as value V is chosen by abortable consensus at ballot B, then V is also chosen at all the ballots which are higher than B. Okay, and from here we can actually see that the rest is quite simple. So we just need to fix a ballot B to be the lowest ballot at which some value V is chosen. And then we just apply this property here. So this is actually property P2, right? So we apply property P2 and we conclude that V is also chosen at all ballots greater than B. Okay. And the abortable consensus, in fact, returns a value which is chosen if it returns something which is not abort. And therefore, only the chosen values can be decided. So the values which are different from abort are the chosen values, and they are those which are returned to the high level, to the leader protocol. And therefore, the chosen value is the one that is going to be picked by the leader as a decided value. The leader will decide this value and it will propagate it to everyone, so everyone will decide the same value. So that means that we have agreement. So now for termination, we know by the properties of the eventual leader detector that we are using that eventually some correct process P will be permanently trusted as a leader by all correct processes. Okay, so that means that P will be the only process in the system that will be executing the code triggered by this condition, okay, that we have seen in the leader pseudocode. And now the next important bit that we discussed is that my ballot keeps increasing. And eventually, that means that P will call abortable consensus with the ballot which is greater than any value stored in the val variable of any process. And as we have seen, this is sufficient for every process to not ever return a negative acknowledgement. Okay? And once this happens, abortable consensus is guaranteed to return a value which is not abort, causing process P to decide value V. And once it decides, it will broadcast it to all processes, and so all other processes will be able to decide, and we have termination.